welcome to all of you and all the participants here. This is one of the other next webinars under the bannership of Focus. I hand it over this mic to Mr. Dominic, who is our vice president, and he will say a few words about what we do in Focus. Over to you, Dominic.
Oh, thank you, Jatin. Good evening to everyone, ladies and gentlemen. This is our sixth webinar on various aspects of building resiliency. So this is today's interesting topic, been sponsored by Eminent International. So he'll be joining as a third speaker. So to begin, we'll like to introduce Focus. Can we play the video?
We are delighted to present to you the Forum of Critical Utility Services, the acronym of which is FOCUS. Much as the acronym suggests, the role of the Forum of Critical Utility Services is to bring in focus all that concerns the construction industry. This is not just for India, but for a coordinated construction industry world over. For those of you who may not be aware, this initiative is to prepare and present a platform where all the verticals of the critical utility services of the construction industry forge into one formidable group that will strive in building unity, aid in diffusing misconceptions, and present itself as a platform for discussions amongst these bodies of professionals. This initiative was born on the 26th of October 2020, when the world was almost silent from the after effects of the pandemic. We say silent because the cry for help and riddance from the clutches of the pandemic were deafening. There simply was no place that was safe anywhere in the world. None of the formidable structures that man had erected was safe for protection from the pandemic. It was during these times that we decided on creating a platform so as to be able to present improved and concerted methodologies of developing projects that shall not just be sustainable or resilient, but also deliver safe environment and a valuable business opportunity to the promoters, not just for some time, but for long time to come. Times when another generation will inherit the good work that we do today. Our efforts begin with drawing the strength from the fields of architecture, electrical, plumbing, HVAC, safety, fire, security, illumination, vertical transportation, IBMS and IT, solid waste management, and last but not the least, facility management. Bring them together and forge them into one strong wheel of change to deliver structures that stand in harmony with Mother Nature on planet Earth. And this, ladies and gentlemen, is our mission. Only when we come together and share our ideas and aspirations will we find the stumbling blocks. It is here then that when we are together and focused towards one goal, we will jointly be able to understand and address our challenges as one formidable force. Not just a force in India, but for a global movement that will find solutions, opportunities, and the means to address productivity, safety, quality, developing skills, training, evolving standards, and ensuring their implementation, thereby becoming centers of excellence and setting benchmarks for generations to pursue and improve. And this is our vision. We have embarked upon reaching out to various verticals of the critical utility services. We will thereafter jointly present our cause to the government and policymakers. We will present our vision to the builders, and we are confident that we will break the shackles of inequality, indifference, ignorance, and mistrust, and build a world that is one with nature. Ladies and gentlemen, we are not here to conjure a forum, but we are here to establish a body that shall have trust, integrity, and honesty for its foundation, and stand on the pillars of knowledge, commitment, enthusiasm, and foresight of its people. Our invitation to you is open. Come and become a part of Focus. It is your contribution and support to Focus that will make a difference to the new India that is being created. Let's join and make this the Bharat that we wear, shining, prosperous, bright, and a true world leader. Let's now focus.
Thank you, Lakshmi. Let's now focus. That's the last statement we are making. So I would like to introduce the focus in very short. What is our mission and vision? Can you go full screen, Lakshmi? Yeah, can you go full screen? Yeah. So, to my fellow friends, ladies and gentlemen, the mission of Focus is to unite existing professional society for coordinated action towards an intelligently built environment, promote sustainable practices and technology integration. The vision is very clear: a world where innovations and technology drive the transformation of the built environment, ensuring sustainability and resilience. So, if you look at our membership, which is growing every month, average 30 to 40 members, and we are built on very strong values to bring all the society together. We are not here to, talk on a particular critical services, but in fact, we wanted to bring in every professional, every society together to carry it forward and make the building sustainable, resilient, integrated, and intelligent. So that's our on these values that we have built this focus. So let's move on to the introducing our speakers. And I would like to introduce as a committee, our managing committee, headed by Mr. Ashish Shakeja, who's the president. He is based out of Delhi. Then we have Dr. C. Velen. Then the vice presidents, Velen Saab and Sandeep Shikre, and of course my colleague Jatin, who's here today, myself, and General Secretary, Mr. Ravi Shankar Pandavan. So this is our managing committee. And myself, I come from a fire background, so I've been there since almost 35 years. Let's go to Jatin, Lakshmi. So Jatin, again, is a well-known face in the industry, is National Director at Colliers International, over 18 years of seasoned expertise in the Indian real estate. He's managing projects life cycle domestically and internationally. Of course, today he's from Dubai and he's expanding his reach beyond India. So Jatin excels in design, procurement, and overall development, offering invaluable insights on technical due diligence. So his leadership is guided teams to deliver value-added suggestions, benefiting clients with cost-effective, timely, and buildable solutions. Through his collaborative approach and wealth of knowledge, that Jatin contributions resonate across multiple projects, enhancing outcomes and client satisfaction. He is one of the vice president with so much of passion in driving focus to the next level. Welcome, Jatin, and I'm sure you will be delivering the opening remarks after I finish introducing other speakers. So can I move on to the other speakers' profile also, Lakshmi? Then Jatin can take over. So we have, the moderator of the session, Vinod Pundargi, with the extensive experience.
So we lost Dominic there, but Vinod comes with a huge experience for 25 years in facade industry. Vinod has handled quite a number of projects, and in 2013 he started a new consultancy called Aspect Facade. And today, with Vinod's expertise in facade design, value engineering, costing, project management, business development, there are numerous works which are happening. And happy to have you here, Vinod ji. Thank you for joining us today. Yeah, Reggie again come from a very niche background of testing and commissioning. He has been there in this industry of facade from 23 years and overseeing numerous activities, doing a lot of tests in GCC, Middle East, and India. Amazing work. And Reggie also holds a very key industry credentials, including his own certified training in airtightness in BSRIA UK and from RetroTech for integrating testing. So thank you, Reggie, for joining us, and
Thank
good to
you.
have you here, sir. Right. This topic is very close to us. It resonates to the resiliency which the focus mission and vision is all about. All our webinars have covered various topics around right from ranging from DGs to climate changes to facade now. Facade resiliency, it is basically refers to the ability of the building and the building's facade to withstand and to adapt to the changing environmental stresses and extreme events which we are facing today, including the climate changes. Which basically the issue and issue is to identify this and ensure the safety and the comfort of lot of of the occupants inside the campus. Some of the key resiliency factors are structural stability issues, which I am sure Vinod will cover more in his seminar. The performance of the facade in terms of thermal, the resistance to the weather conditions, the adaptability issues, and how to quickly change based on the usage of the building, the minimal of the maintenance which are required. So these are certain aspects of resiliency when it comes to the facade, and it's important to understand more in depth and detail and deep dive on that, which I'm sure Vinod and Reggie will cover in their presentation topics, and they come with immense background and knowledge about it. um, there are various strategies which are basically adopted currently worldwide. Some of them are right material selection, innovative design solutions, which a lot of stakeholders work together, right from architect to facade consultant to designer to testing to the contractors. They all work together. Important is also to do regular inspections, and that's something which Reggie will also cover about it, and Vinod will also cover in his topic about it, how to ensure that periodic inspections are being done to maintain the facades in the right aspect, and so that facade is ready and it doesn't becomes a during one of the, you must have seen on the LinkedIn yesterday morning, it was posted that the entire curtain wall came down right in one of the buildings. So these are the challenges which are happening because of the ever changing dynamics of the conditions of the facade which you're facing, including energy efficiency. This is another important factor from a resiliency parameter. How efficient and how good is my building all about, and how we can start. So facade plays a very important role, all of you know, gentlemen, ladies. So here we are, without taking much more time from you guys, let's deep dive on with Vinod G's to start with first, and over to you, Mr. Vinod. All the
Thank you.
best. And we have a close to about 80 webinar panelists and participants here. They're all eager to listen to you, Vinod Ji.
Good evening, everybody, ladies and gentlemen. Thank you, Focus, for giving me this opportunity to present on facade resiliency and performance. So as Mr. Jatin was telling about the resiliency and performance, I would continue from there. So today we will be discussing about what is facade resiliency, important aspects of facade resiliency. That is durability, longevity, safety and protection, comfort and well-being, sustainability and energy efficiency. And what are the key aspects for the performance as well as the facade resiliency is the structural resilience, functional resilience, adaptive resilience, environment resilience, fire safety resilience, and a case study of a project where we have worked on. So I'll be sharing some details of that project as well. Let us go one by one about the facade resiliency, important aspects of facade resiliency. So let us understand what is facade resiliency. So it refers to a building's facade of how well it can adapt to various environmental actions, structural requirements, functional challenges that ensure the durability, safety, and performance of the facade under different weather conditions, having minimal maintenance and repairs. So importance of facade resiliency shows first, let us look at the durability and longevity. A resilient facade extends to the building's lifespan, minimizing costly replacements and repairs. What we mean here is the facade should be strong and durable so as to weather the climatic actions which would be imposed on it from time to time. So as to save on long-term maintenance and environmental impact. Then we have safety and protection. The other parameter what we look at is the design facade should perform under various conditions, whether it be strong winds, rains, seismic actions. It should protect the occupants as well as the surrounding environment. So for this, the facade has to be structurally stable, which ensures there are no failures, collapses, and potential injuries to the people occupying the building or the people around it. Then we have this comfort and well-being. So when we design a facade, we should ensure that the indoor environment for which protected cover is being given by a facade should provide an environment which enhances the thermal and acoustic information. Thermal insulation in the sense we mean the kind of protection we give when we design the facade. Thereby, it reduces the heat gain, reducing in energy consumption, making the temperature within the building comfortable for the occupants. Next, for the well-being, again, we have this acoustic insulation, which reduces noise so as to give a proper working or a living environment to the occupants. Next we have is sustainability and energy. As Mr. Jatin was saying, just a video what you can see about urban heat island effect and its effects on temperature, the weather.
Than their surroundings, a phenomenon known as the urban heat island effect. During the day, the sun can warm buildings, streets, roofs, and cars 50 degrees or more hotter than the air around them. Unlike their rural counterparts, the building's materials are dry, limiting evaporative cooling. Plus, at night, these materials release heat at a much slower rate. On average, a city with 1 million people or more runs about 2 to 5 degrees hotter than its surrounding area. In addition to the burden of heat, stagnant air conditions often occur during heat waves. In cities, that traps pollutants near the ground, greatly diminishing air quality. For Weather Nation, I'm meteorologist Carissa Kloss.
So when we speak about sustainability and energy efficiency, we should look at the materials what get the facade built into. So while choosing the material, we need to look at their thermal performance, their carbon footprint, and furthermore optimizing the design so that we get proper natural light, ventilation. So there are different strategies what we use, active and passive strategies for the energy efficiency of a building. So these come into play when we design a facade where we give optimum ventilation and thermal comfort. So now next, moving on to the
Heat is the
key aspects of facade resilience. So we have here around 5 important factors what we look at. First would be the structural resilience. Structural resilience, here we look at the kind of loads what come onto the facade. They being whether dead loads, live loads, or impact loads. So these loads are to be taken into consideration while we design the facade, and that depends upon place to place. A place with a for example, the eastern coast of India, the wind loads are much higher than the western coast. So the design would vary depending upon the location, the building height, the building configuration. So the structural engineers analyze these factors and then choose appropriate materials, connections, and then the facade is designed for proper stability and durability. Next comes seismic performance. For places which are seismic zones, we need to design the facade so that there is proper movement capability in the facade. During a seismic action, what happens is the building tends to move. So when the building moves, the facade should be capable to take these movements. Either that's the reason we have this three-dimensional brackets what we have in our facade, so that movement is given on all the three axes. Then comes for a building to be structurally resilient, all the materials what get into a building it have to be durable. So while selecting the material, the choice of materials and the construction techniques directly impacts the facade's lifespan. So when we look at selecting the material, we have to look at the durability of it, the strength, the right grade of material for the right application. So we have different kind of materials available. So, but we need to choose the right material for the right application. Then we have this functional resilience. Functional resilience, main thing what we look at is how easy it is to maintain and repair. Not usually intended to repair, but how easy it is to maintain. Functionally, when we look at facade, there are two important criteria what we look at. One is the acoustic insulation, so that we don't get the noise from outside to inside. So as to make the living occupants or the working people within the buildings work without any disturbance or noise. So there are mitigation what we do, like we use double glassed units, and in certain cases, if where required, it can be at triple glassed units or laminated double glass units. So as to reduce the noise interference. The next thing here is for a building or the facade to be functional, it has to be air and watertight. I think in the next presentation, Reggie would be speaking more of that. So the facade, when we design, it has to have a proper drainage system, proper pressure equalization, so that there is proper insulation or proper cover for water and air not to ingress into the facade. Then if these both and all have to perform, it has to be a proper maintenance free facade. So that if it has to be maintenance free, then we need to still check. We need to have periodic inspections, check how it is performing, where repair needs to be done. Unless until it is checked or it is not repaired, then we'll not be having a proper panels. So whilst designing facades, we should see to that they are easy to maintain and repair. Next we have is adaptive resilience. So what we see here is in the in this in the changing environment, in the previous slides on the heat island effect, we saw that there are temperature changes of 2 to 5 degrees. So that's a huge number for human comfort. So whilst designing facade, we should have that flexibility of upgrading or updating the facade system, so that it can take any new components or fixtures which will add on to the performance of the facade. Like one thing being photovoltaic panels, which can be later on added, or we have to have combinations of facade, the modular system, such that when required, this can be mounted and used. And when we see there are a lot of climatic changes, there are unseasonal rains, heavy winds, and wind patterns changing across. So we need to have a facade which adapt to these changing climatic conditions. Next is our environmental resilience. As we speaking the previous slide as well. So what we see is there is a lot of extreme weather conditions which is happening. So the facade needs to be durable so as to have a properly designed system for all the changing weather conditions and extreme rains, winds, for that. And then there is this UV protection what we have. See, the ultraviolet rays have a major role in disintegrating some of the materials and color fading. These are the effects of ultraviolet rays. So when we design and propose a facade, the facade should have durable materials which have ultraviolet resistant coatings. So we use laminated glasses, shading devices, so that the direct effect of sunlight or the UV rays are mitigated. Then we have this thermal performance. Thermal performance is when we don't allow the heat to get in, or in the or in the for a tropical climate of India, it is we majorly see that the heat doesn't come into the building. On the cooler environments, we see to that since those buildings are heated, so we don't let the heat to go out. So, in the majority of scenario, what we find here in the Indian context is the facade needs to be properly insulated so that we minimize the heat loss, heat gain in the summers. So as to maintain regular indoor comfortable temperatures. So there are mitigation strategies what we use like thermal breaks in the facade structure and having low E coated glass. We have single coated glass, double coated glass, and there are different combinations of glass for so as to address this thermal performance. Next we have is fire safety and mitigation. So how can we make the building so that it is more fire safe? So there are around 6 parameters what we'll be discussing. First thing is the material selection. So for any material which gets into the facade, we need to check how fire resistant it is. There are different categories and grades and combinations which we look at, and the building needs to be designed so that the choice of non-combustible or fire resistant materials are used. Likewise, in the glass, we have tempered glass. Then cladding we do have, which we have fire rated claddings, A2 grade, A1 grade, and there are special coatings to resist fire. So those are proposed while selection and proposing materials. Next is compartmentalization. Compartmentalization is nothing but we just barricade and make the whole facade into compartments so that fire doesn't spread from one floor to one floor or one room to other room. So fire barriers are created, and see to that there is no fire propagating within the building. So this can be one of the strategy or a mitigation strategy so as to contain the fire in case there are fire. Then next is ventilation and smoke control. As we all know, during a fire incidents, it is more the smoke is which creates more of casualties because there is no proper visibility, and the people who are people or the fire personnel who go to rescue or the people who are trapped, we see that smoke is a major hindrance for visibility. So they would not know where to go, where is the exit, and this one. So there are mitigation strategies like we have this smoke control actuator vents, so that in case of a fire, the facade opening is connected to the IBMS. So that would send a relay, and this would automatically open the place where there is a fire alarm. So next we have testing and certification. See, fire being a very critical and important parameter which we need to look at, and there are many instances which have been happening in the recent past. So the number of instances are growing. So whatever material we propose or we use, those material needs to be tested prior to using. So there are standards for it, like this NFPA 285 or EN 13501, which certifies the product prior to the product being used. And there are certain testing agencies also who certify the products for what, under what testing conditions and what end conditions they are tested. So the certifications just ensure that the materials assemblies follow strict fire requirements. Then what we have is maintenance. So in case of fire, as I was telling previously as well, there is this maintenance and repair is what we need to take inspections, we need to take regularly, so that we get to know if there are any potential breaches, or if there is any seals or fire barriers are not working, or there is no continuity in the fire barriers. So we need to have regular maintenance. I think most of the buildings have this drills for the fire system being in place, whether they're working. But likewise, even for facade, the perimeter seals, we have the actuators or the wall to room seal. These needs to be checked periodically, so that we are it is assured that they are in place and they are working for the intended. The next we have is the integration with the overall safety plan. As I was explaining in the actuators, so that needs to be connected to the IBMS. So the facade fire safety should not be considered in isolation. So, but as the building's comprehensive fire strategy. So we need to see that this is in line and coordinated with the detection systems, sprinklers, and emergency response plans. So this ends the part of facade resiliency and performance. So I have a case study wherein we had worked on a project, high-rise building of 11 floors and 330 meters long. It's a IGBC platinum rated building. So I'll just run through a few of the things what were considered during the design of this building for facade. So first was material selection. So in this project, we had used unitized curtain wall panels, which are factory fabricated under controlled conditions and with insulated glazing units and spandrel panels, so as to provide a superior thermal insulation, so as to reduce the uh, energy consumption. All the design was done as per the HVAC requirements and the IGBC guidelines. The glass types were chosen for their durability, and they were again checked for all the UV radiation, weather conditions, so as to give a long-term performance. The facade structural integrity. So the unitized system and other systems were tested on site as well as on lab test. So here is a video of one of the tests which was carried out. So here we had tested for air, wind, and water. You can see wind-driven. We are simulating a wind-driven rain situation. So the facade was tested here for all the conditions of air, water, wind, and seismic actions as well. So as to check the movement capability of the brackets, the components, the connections, as well as there were operable windows which were and the whole of facade for the performance unit. What we had done, we had tested for both the negative and positive wind pressures. Usually we test this for 1.5 times the design wind pressure for what the project is designed. So this was about the structural integrity of the facade system, which was proposed, which is installed and is working now. Then we have again the sustainability criteria, where the building is IGBC platinum rating, with its high rating, all the facade components, the glass performance, they were all checked so that we qualify for the platinum rating. Thereby having a double coated, we had a combination of 5 types of glasses. So all the glasses were with low E coating, which helped us significantly reduce the cooling loads for the project. Additionally, we had programmable lighting within the facade of the aluminum fins, so that we don't have continuous, and lighting can be done when and required, and as per our requirement with any, it had a programmable feature, so that we need not keep the lights on all the time and waste on energy. That would be lit up only when it is required, and on few occasions and celebrations only. So what are the performance outcomes with all this resiliency strategies? What was used for the project? What we found was the building demonstrates an exceptional thermal performance. There is reduced heat gain, so as to lower the HVAC costs. And in this project, we had a 50-50. This one, 50% of it was a panel with the insulation, and 50% of it was the facade glazing was with vision glass. So we have a better insulation from the indoor comfort point of view. So this is now almost 2 years, and the building has gone through different environmental changes, and we see that it is a proper energy efficient facade what we have. So on concluding on this, what we find is facade resiliency is the critical aspect of modern building design, so that we need to ensure that all the external factors which act on the facade should be able to withstand these challenges while maintaining its performance, providing safety and comfort to the occupants. So this is what I had for this presentation. Thank you. And I would like to just brief you about our company. We are Aspect Facade and Engineering Consultants. This is a collage of projects what we have worked on and we are working. So ours is a 11 years old plus company. We have around 60 client collaborations, and we have completed almost 200 projects. And other good thing what I wish to inform here is we have already consulted for projects of over 1 million square meter of facade, which is realized, installed, and working safely. So we provide facade consultancy services along with different building segments such as commercial, residential, hospitality, as well as infrastructure projects. So these are the services what we provide. We provide facade consultancy services. We do have a vertical for green building rating for sustainability, where we do green rating compliance for facade. Then we have technical due diligence, wherein we check for audit installed facade. This is the footprint of our projects where we have been working, where we have worked and we are working. That's it from my side. Over to Reggie, who will be taking the next.
Thank you, sir. It was very informative, and I am sure audience has a lot of questions during our Q&A session. So we'll wait for the questions to come in. But over to you,
Okay.
Reggie, and to take it forward to the next one. Thank you, Vinodji. Very informative.
Thank you.
Reggie, over to you.
Thank you, Chiranji. Thanks a lot. And thank you, Vinod sir. It was a nice presentation. Now, moving towards to the eminent. Good evening, all. Am I audible? My name is Reggie Bhami. the director of Eminent International Testing Center. We are Eminent International Testing Center is one of the largest facade testing laboratory located in Hyderabad in India. We have office in Dubai. We do on-site testing in Dubai. And we are NABL accredited laboratory for ISO 17025 for various standards like ASTM, BSEN, CWCT, AMA standards, and Australia, New Zealand standards. So the topics today, what is why PMU test is important for facade industry. So basically, when you have the facade testing, it is validating your design. Initially, you're designing the system, and before you're going to install it on site, you need to make sure the design is properly done or not. So when the system, the sample comes to the laboratory, we can test all the requirements as per your project requirements, the project specification requirements, like air infiltration, what is the air leakage, how the air leakage is passing through the facade, how the water leakage, how the water is preventing the facade, and structurally, how integrity, how adequate is this facade. This can be tested and identified at the time of mock-up testing. Then you can proceed with the installation. So you will have a peaceful mind and make sure, and my facade is tested, and it is the air leakage is within the limit. The water, there is zero water leakage. Structurally, it is within the limit. And obviously, we all wanted to cut down the cost. So when we do the facade testing in the laboratory, the cost saving is one of the facts that tailor-made facade, you will do the testing, you design a facade system for your project as per your project requirements, and then do the system, do the testing. Then you will understand what is aluminum required for, or the amount of aluminum, how much is required for your project, and how we can cut down the cost. So all these kind of things you can do at the time of mock-up sample testing. And obviously, the test will be conducted as per internationally recognized standards. Okay. So if the facade is not tested, what is the effect? What will happen? So it's like, what I wanted to say is you're taking a 50-50 chance. Like maybe it works. There will not be any leakage. There will be no water leakage. There will be no air leakage. System structurally, it is fine. But what if it is not done properly? If it is not tested and you don't know what is the condition of your facade. So if there is an air leakage, what will happen? So if there is an air leakage, for example, you have hot air is outside, and you have a normal temperature inside the room, and when the summer is there, the hot air is traveling to the your house, your apartment, and what is happening? Your internal elements like your valuable furniture, your luxurious flooring, your drywalls. It's all going to damage. And not only that, you are also, there can be a chance of, molecule happens in the apartment, in the building. So it will affect your health also. Like you have asthma or allergic issues. So these kind of things also can happen if your building is not completely airtight. The next thing is the water infiltration, water leakage. What will happen if you have a water leakage? Nobody wants to have a leaky buildings. So, for example, you are going away from your building, your apartment for a vacation. Let's say for a vacation for 1 week, and you have a heavy rain at your city. What will happen when you come back? When you look at your apartment, you can see the apartment is full of water. It's going to damage your everything. Your expensive items all are damaged. So all these kind of things we could identify at the time of mock-up testing and make sure this is not happening to your building. structural failure. We are facing so many issues in our country worldwide. The issues is like facade is falling off because you are not properly tested your product. Your bracket design is not done properly. Your aluminum is not done proper. Aluminum calculation is not done properly. Your structural calculation is not done properly. So you have vibration on your buildings. So sometimes people are complaining, like when there is a heavy wind is happening, none of my facade is vibrating. So all these kind of things you can identify at the time of testing. Whatever the changes you wanted to make it, you can do it at the time of testing and proceed with the installation. Your building will be safe. The next is the seismic testing. So seismic testing, like we are conducting the testing, we are simulating seismic movement in the laboratory, which you cannot do at site. So we are creating an artificial movement of facade in a left and right side and vertical and downward sides and frontal movement. We can artificially create all this movement and make sure the facade is designed properly as per your requirements. So how the facade testing is carried out? So basically, once the design is approved, fabrication is done for the testing sample, we will prepare a test rig for you to install your facade. That is the first stage. And then the second stage, once the rig is ready, you bring the sample and do the installation in our laboratory. And then the third stage is the installation is completed. Then the third stage, you will be completing the installation. And then the fourth stage, we are closing the chamber and make sure the chamber is completely airtight. Then we can proceed with the testing. We can conduct all the testing, whatever you require for you as per your project specification. I will be explaining all the testing, what we can do at the laboratory at one site. It's coming up. So all this process will be taken, will be completed within 15 to 20 days time. So these are the testing what we can do in the laboratory. Like you can see, the air infiltration testing is conducted as per ASTM 283 and ASTM 783 standards. BS standards, like for doors and windows, we do the testing as per BSCN 1026 and BSCN 12153. Structural load testing we'll be doing with the ASTM 330, BSCN 12211. You don't need to remember all these standards, okay? This is the standard we follow for the testing. That's what I wanted to tell you. So if any doubt about the standards, coding and all, you can just send us, you can just get back to us, we'll give you all the information. So water penetration test will be conducted as per ASTM 331 and ASTM 1105 and BSCN 1027 for the doors and windows. Dynamic water penetration test can be conducted in the laboratory. Dynamic water penetration test is actually like you create an artificial wind along with the water. So it's like an artificial wind with water. The actual condition, what is the wind and rain comes and how your facade is going to react, how the water going to ingress into the building. So all these kind of things we can test it at the laboratory. The next is the seismic testing. Seismic testing, we have a standard called ARMA 501.4 for the lateral movement. We create a jacking system. We install a jacking system. We create artificial movement and come to know how the system is behaving in terms of building movements. So seal degradation test is one of the interesting tests. The thing is like, your gasket, your silicones always exposed to the outside environmental conditions. So time to time, there might be a chance to damage your seal and damage your silicone. So damage your gaskets. So this purpose of this testing is how we do the testing is we remove a part of sealant or gasket from the facade system and we conduct the test again, like a water test again, and make sure even there is a minor crack on the sealant or even a minor gasket damages, still the system is performing well. So that's what the whole idea of seal degradation testing. The next is thermal cycling testing. It is not that common test in India, but nowadays everybody is facing the global warming, and also now the market requires like thermal cycling testing is also to be part of performance mock-up testing. So once the mock-up testing is completed, what we'll do, we will install another chamber in front of the mock-up sample and create an artificial temperature. The normal temperature, for example, is 22 to 24 degrees Celsius. We will increase the temperature up to 80 degrees within 1 hour time. Then that temperature will continue, the 80-degree temperature will continue for 2 hours. Then this will be bring back to the normal temperature in a 1 hour time. Then the temperature will go down to minus 18 degrees Celsius. From the minus 18 degrees Celsius, it's going to maintain for another 2 hours. Then you're going to bring back to the normal temperature of 22 or 24 degrees Celsius. So this is called one thermal cycling. This is a one cycle. So depending on your project requirements, it can be 3 cycle, it can be 6 cycle, 9 cycle. The temperature we are creating is like, for example, we have in Hyderabad, we have a 40 degrees maximum temperature at summer time. So we are creating the extreme level of 80 degree, double of the temperature. So this is what thermal cycling testing. Then the railing and balustrade testing. These are very important testing for the building occupants. I mean, we should consider the safety of our occupants who is staying in the building. So these testing can be conducted in the laboratory and on site, like with various standards, ASTM 935 for metal railing, ASTM 2353 and ASTM 2358 for glass railing, and BSEN 6180 and BSEN 6399 standards are for the railing and balustrade testing. So then the next one is BMU pull-out testing. The BMU pull-out testing is actually, for example, we have a building is completed and we have a BMU, a building maintenance unit is installed on the building. So, for example, the people are removing a glass, or they are do some maintenance work on the glass, or they're cleaning the glass. Suddenly, you imagine there is a heavy wind happen, and the people has to be safe, right? So the building facade itself, at the facade itself, nowadays we are designing like a BMU restraint socket. So the BMU restraint socket will be installed on the facade. So when the cradle comes down, this cradle will be connected to the facade system. Then that movement, when there is a wind or any movement is there on the facade, it can be arrested with the restraint socket pin. So the cradle will have a weight like 200 or 300 kg of the weight of the facade is there. And I mean, the BMU weight is there. And plus the BMU weight, 1 or 2 people will be in the BMU. The BMU means building maintenance unit. It's like a cradle, can be cradle or any suspended platform. That's what ideally BMU, what it is. So the BMU is arrested on the facade system and make sure when there is a wind or any turbulence happens, then the BMU should not shaken or it should not move away from the location. And this will be tested at the time of mock-up testing, like laboratory testing, and make sure the facade is taken care of. The facade will be taken, even the BMU load. So the next test is the water hose testing, which is common testing everywhere. Everybody is doing this testing. The water hose testing as per AMA 501.2. It is validating some workmanship. If there is any missing sealant or gasket joints are not done properly. So all these kind of things can be identified when we do the water hose testing from exterior side of the facade, and you witness the testing from inside and make sure there is no water leakage in the building. The impact testing. Impact testing is again BMU pull-out, BMU or any other exterior access or something like that. it's already installed on the building, and the people are working outside with the BMU, and the BMU is moving in and out. BMU is moving on both sides. So once the BMU is hitting on the glass, what is the effect of the glass? So these things can be tested in the laboratory with various standards and make sure the glass is safe, even the BMU is hitting on the glass. So mainly this test will be conducted as per, for curtain wall, this test will be conducted as per BS-EN 14019 standards. We have different impact testing is there, like Skylight, we have CWCTU, technical note 66 and 67. Balustrade impact testing is there as per ASTM E2353 standards. So for glass itself, we have tempered glass or HS glass, heat strengthened glass. We have the standard of BSCN 12600. So the next is side chamber testing. So what is side chamber testing? So now we were talking about facade laboratory testing before the aluminum or the entire system is going to install on site. We make sure the system is performing well and tested in the laboratory, and we got a proper result. So the side chamber testing is validating the laboratory test result. For example, the laboratory test is done. The sample is the product is started to install on site. We need to make sure the people are installing in the same method they are using and the same manner they are doing the installation. That can be tested. I mean, those information can be identified by conducting a side chamber testing on site.
Some questions which are there on the chat box, and
Yeah.
while Reggie comes back, we can possibly answer them.
Okay.
How exactly is the compartmentalization
How
achieved?
exactly is compartmentalization achieved?
It's been asked by Mr. Sandesh, and
Sandesh Kumar.
yeah,
Yeah.
yeah. So if you
Hi,
can,
Mr. Sandesh. So what we do here is with reference to compartmentalization, with reference to fire shaping. What we do is when we have, suppose for example, we have a hotel project where there is floor to floor separation, but we also look at separation between room to room, or another situation where you have a dead wall and it is cladded, and then the same facade continues to a glazing facade. So there is a transition happening of a glazed facade and a non-glazed facade. It can be a tile cladding, it can be a aluminum sheet cladding, or any other kind of a cladding. So when there is this transition happening, so there we have this uh, a barrier system, compartmentalization. In sense, what we do is we provide a barrier there. Or there can be another situation wherein we have a high rise and we have to mitigate this floor to floor propagation of fire. Even there, we give this barriers horizontally as well as vertically.
thank you, sir. It's nicely answered. And apart from that, at architectural level, we can still use the compartmentalization. Reggie, sir, you're back to the thing after your network issue. We can resume um, your presentation, sir? So, request if you can, run the slides quickly, next 5 10 minutes, please. You're on mute. Reggie, you're on mute.
Okay. Yep.
Yeah,
So
go ahead.
the side chamber we were discussing about. I'm sorry about that. There was a network issue, and I'm able. Can you see my screen?
Yeah, we can see your screen. There's a little bit
Yes.
of disturbance or a network issue. You can switch off your video, but can we quickly run the slides? It's already 5:03.
Yeah, sure. The next is building attendance testing can be done as per BSCN standards, and we can do the pull-out testing, we can do jacking testing, boat testing, glass testing, and all can be done. And now we started the testing, louvre testing, one of the interesting testing as per BSCN 130. 3.0 standard, and currently Eminent is only one is doing this testing in India. And now I wanted to take some special cases, like we have recently done one testing in Hyderabad. Actually, Aspect Facade, Vinod sir was the consultant for the specialty of this project. Initially, the design was submitted by Shuko, and the aluminum they were using like 9.1 kg per square meter. And the project requirements was based on the wind load, they wanted to revise the design. They wanted to redesign it. And Shuko redesigned the system based on their project requirements. And the aluminum cost is cut down, the weight of the aluminum cut down to 7.1 kg per square meter. Overall, cost, they could save 20% of the total cost of aluminum. This system was tested in Eminent, and it went well and good, and it was tested up to the wind load of 2.5 kPa. So the next is one of the projects again in Hyderabad. This is one of the largest facade. We have tested 12.5 meter width and 9.6 meter height and 9 meter height. This is designed by Elevation Facade. And this the specialty of this system, 3 different components included in this sample, like straight facade, inner corner, outer corner, and segmented facade with fins. So what the specialty of this one, the entire element of the elements of the facade is tested in one time, and we could identify the results of each elements, how the behavior of the element structurally, in terms of air infiltration, in terms of water penetration, how it was. And I'm not going to, I mean, this is the dynamic test is going on with the same sample. So this is one of the different sample tested in Eminent, which is normally what is happening, the facade is tested with only the glazing system. Usually the perimeter sealant is not included for the facade system. But this is special requirements from facade consultancy, Mr. Funny. He has, he wanted to test the perimeter joints along with the facade system. So this is, as you can see the drawings here, the perimeter is also included in the part of specimen area, and we have tested, and it was satisfied with the requirements. The next is the standing seam roof integrated with a skylight. So this is tested like for our airport project, we have tested in our laboratory. Standing seam roof is having a gutter, downspouts, and along with a skylight system. So the specialty of this testing, we are testing at different elements. We are checking the combination of all these elements, how this is going to be behaving in terms of air leakage, in terms of water leakage, and structurally, how this is going to behave for the entire system. So these things has been tested in the laboratory, and this is the advantages of laboratory testing, so that you will be able to identify what is your problem for a facade, what is your problem with the design, that you can identify, rectify that before it proceed with the installation on site. So I'm going to take you now with Eminent, a small tour for Eminent. You will see what is Eminent International Testing Center, our facilities and all. We currently have 8 facade testing chambers, and we have 5 numbers of window testing chambers. And we have several different type of testing, like we do the all kind of glass testing, and we do thermography scanning. We have louvre testing. A different type of testing we are interested to do for the industry and to help the industry, to make sure that the industry, the Indian industry especially, we should get a proper safe building. So That's it for now. From my side, it's almost done.
Thank you, Reggie. It was
Looking forward.
very informative, and I am sure audience will have a lot of takeaways. Yeah, it's an interesting field of testing. Not many test labs are available in the country today, but I'm sure the emphasis on having facade tested in completeness, including the sealant, is something which is a key takeaway, and not just the glass. So this is an important parameter, and it will improve the resiliency of the building facade as well. It's a really informative one. I'll move to some of the questionnaires which are there on the chat box. Mr. Rakesh Chaturvedi has written a question, and I would direct it to again Vinodji. What are the challenges in natural ventilation, if any, by using windows? To my best of the knowledge, there are no such challenges. It's actually the natural ventilation is the best of the system, but of course, your air conditioning, requirements coupled with openable natural windows, we need to figure out how we do that. But apart from that, what are the other challenges in occupants rescue by firefighters and firefighting operation challenges due to smoke traps? Vinodji, over to you, and Reggie, you
Yeah.
can add to a point to that as well.
Yeah. Coming to Rakesh ji's first question of what are the challenges as of natural ventilation by using windows. So as you told, the best option would be to have a natural ventilation, which we would get fresh air as well. But what happens in the times what we are living in is most of the buildings are air conditioned, and it is not advised to keep it open, as there would be precious conditioned air, loss of conditioned air, which we will be losing. Likewise, it has to be maintained as well. If you can't leave it open, then there are instances of rain coming in and other things. So there is dual nature to this. Like what you have is, one is from the maintenance side, so that if it is opened, it's the right responsibility of the person to close it back, or the maintenance staff to maintain it properly. That is the thing. And the second, what are the challenges in occupants rescue by firefighters and firefighting operation challenges due to smoke traps? First thing is visibility. And when the fire personnel come in, they would not know the proper layout of the building, or even though if they have gone through with the fire maps or anything, but the placement of the furniture, the chairs, and other things would be different. So the main challenge what we see here is the visibility.
Reggie, just
Or
to
or I'll take this up.
what
Yeah.
is the time period as per you where the seal degradation or the time is required for the replacement or to carry out the maintenance? In your experience of being in this industry, what is your analysis around the time period? Is from Mr. Naresh Yadav.
See, normally, the silicon will withstand for 10-15 years without any problems. And yeah, it is actually, but this is what the the recommendations from the suppliers provide. But it can withstand like 20-25. We can see the buildings with the 20-25-year-old or maybe more than that. Till we don't face any problem. But what we are saying that we can still test and make sure if there is a minor crack on something can be identified and tested at the time of mock-up testing.
So the regular inspection also during post installation is also important to ensure that any element which is not behaving properly as per the required specs are also advancedly notified. And Vinodji, over to you if you want to add a
Yeah,
few lines to
one
that.
is regular maintenance and or regular inspection, time to time inspections, and other thing is the usage of the window. If is it being frequently used or it is not at all used. So this kind of a preventive maintenance would be required, so that if it is not at all used, then it might not open up, or there might be some dust grime collected. So that needs to be checked. So regular maintenance, regular inspection is required. So that depends upon the cycle and where the project is.
Understand.
and
Wonderful,
what
sir.
weather conditions the building is situated. It can be
Yeah.
cycles of 3 months, 6 months, 9 months, not
Yeah.
9 months, at least 3 or 6 months cycle, wherein every window opening needs to be checked for their seals, not only seals, even for the locks, the handles, so that there is a proper and smooth operation of the windows.
Wonderful. Great. Vinodji, Rakesh ji again came back with that in case of a fire, does the natural ventilation is better? Of course, I think from a smoke and fire perspective, what are your ideas around openable panels, national building code, compartmentalization? I think that's the relevant question which Mr. Rakesh is asking.
So in the upcoming codes, I think there would be mandates for windows with actuators. But in case of a fire, we don't know there would be a person available to open it. There are options of natural ventilation which would take place, but on that depends again upon the building size and building size and the use of the building is. Where if it is a smaller building where things can be controlled, or the volume of air coming in and getting out that's controlled properly, then it is good to have a natural ventilation. But anyhow, in cases of fire, we can't totally rely on natural ventilation. So there are firefighting systems, alarm systems, sprinklers. So it is a coordinated effort of uh, all the systems which should come into play. So this would also add in, but not totally insulate from the issues there.
Wonderful, sir. Great. I think we don't have any more questions here. It was wonderful to have you both, you gentlemen, on this focus platform today. Thanks
Thank
for
you.
taking out your time and giving us a nice overview, Vinodji and Reggie. Thanks to all the participants for taking their time out on a Thursday evening, and overshot by about 10 minutes, but I think it was very informed seminar. Thank you so much, and I would like to
Thank you
uh,
all.
thank the admin team of Lakshmi and MV also
Yeah,
here who supported us on this thing. Thank you, everyone. Thank you for
thank
being on
you.
the call. Thank you so much. Bye bye.